So this is where we are at now after we've talked about different translations and stretches, compression, and reflections in lessons 1 and 2. So let's take a look at example number 1. Given the graph of y equals to f of x, okay, sketch its image after a horizontal compression by a factor of 1/2. Okay, that's a good one because we've already talked about that one. Factor horizontal compression by a factor of 1/2, then a translation of 3 units down. Write the equation of the new function in terms of f of x. Now, just above this, okay, just above this, I want to write down the transformation when we do mapping. This is how we're gonna do this. So in terms of mapping, because we all love that, this is, you're starting off with an xy. Okay, so this is your key points. And then after we do some transformation, it's going to be x over b, x over b. Now you're thinking about, well, why is it x over b? It's going to be 1 over b but times x. So 1b times x is just x divided by b, plus h, that's our horizontal translation, comma, a times y, that's vertical stretching or compression, depending on what the a value is, plus a vertical translation. Okay? So let's see. So this is basically what's going to happen here. Okay, so sketch its image after horizontal compression by a factor of 1/2. So when we say horizontal compression, they're already telling us what the factor, what we're multiplying with. Okay, by 1/2. We'll start with our key points, x, y. A factor of 1/2, horizontal compression. That's going to give us 1/2 times x. 1/2 times x. Right? Factor of 1/2. So that means it's multiplied by 1/2. And then a translation of 3 units down. Well, translation of 3 units down, it affects our y coordinates. Because it's 3 units down, it's going to be y minus 3. So far, so good? Now that this is kind of set up, it's a matter of just working it out, and then we'll get to draw the picture. So the key points here are already kind of like dotted. Let's see here. This is going to be -7, 2.
Let's see. I'm getting confused with like the factor of 1/2, but then you have 1/2 x. Shouldn't it be 2x?
Yeah, let's finish this one first, okay? Yeah, we're gonna do that equation later. And then this
is -6.
is it -6? So 1, 2, 3. Yes, -6. Thank you. -6, and then this one is 0, -2. This is going to be 1, 5. And then this one is 5, 3. Is it -3? 2 and yes, 2 and 5. So this is 1, 2, 2, 5, yes. 2, 5, 5, 3. Okay, that's good. Let's take a look at this. factor of 1/2. The word factor, we have to somehow in operation, there's multiply. So we're going to multiply by 1/2. So if I multiply the -6 by 1/2, what's going to be? It's going to be -3. And then here, the y is shifted. It's vertical translation, 3 units down. So that's 2 minus 3, -1. Okay, so this -6, 2, it's been transformed. Now it's the corresponding point is -3, -1. Let's see this one. 1/2 times 0 is 0. And then -2 minus 3, that's -5. 1/2 times 2, that's going to be 1. 5 minus 3 is 2. Let's do this one. 1/2 times 5, which is 2.5, comma 3, take away 3, that's 0. Okay, so now we have the new points. Let's go ahead and plot those points and we'll see what kind of picture we're going to get. Okay. Did it look compressed to you? Horizontally? Yeah, it got kind of like, if I push it in horizontally, it got pushed in horizontally, right? Compressed. And then it kind of went down a bit. Right? And that's what we want. It's compressed by a factor of 1/2. By a factor of 1/2. Now, great, we did that. Now we have to write the equation down. Okay, so here, what's the equation? Y minus K equals to A times F of B times X minus H. It's going to have too much brackets here. A times F of. Okay. So here we have a K of -3, right? A K of -3. So if K is -3, it's going to be Y minus -3. Because remember, it's shifted down, so it's negative, has to be negative. Do we have any vertical stretches, vertical reflection? Nothing, right? So that's assumed, that's going to be 1. F of B. Now the factor is already 1/2. Now therefore the B is the reciprocal of that. It's going to be 2, and then X. And then H, no horizontal shifting, so X is 0 there. So it's going to be Y minus -3. That makes it Y plus 3 equals to f of 2x. Good?
On our test and stuff, if we leave the -3 on the other side, is that okay?
Yeah, that's okay. So bring the -3 to the other side. That's okay. So good. Okay, that's good. So we got the picture, we got the equation. Is that all they want? Yeah, that's all they want.
So in that example, when it has y is equal to the f of x in our final answer, we didn't include the f presumed rate. We can't just do y plus 3 equals 2x.
No, we can't leave the f because the function wasn't quite defined as a specific equation for the function, because this one here is f of x. We don't know how they got that shape. Yeah. So yeah, you do need the f of 2x there. Without this, that looks like a straight line. Yeah. Say that again. Yeah. Are you talking about this? Are you talking about this piece? Yeah. Okay. So let's take a look at that. Like this is kind of the gray area. Let's take a look. Okay. Let's go back. Okay. So here, if the b, the factor is going to be 1 over b. So if this is b, the factor is 1 over b. So if we have a factor of a half, that means the b is 2. Mhm. Yeah. Okay. Did that help a little bit? Yeah. So when you say factor of a half, that means the factor it's being multiplied by a half. On this, let's say here, factor of 1/2. That means whatever x is, because horizontal, so that's affecting the x. The x is being multiplied by a half. Yeah, you reciprocate it. Take the reciprocal or reciprocate. Okay, good. Let's see this one here. Oh, this is going to be, tell me what's going on in this picture or in this equation. Okay, I'll point something. The 4. So the b is equals to 4. The factor of a fourth. Yes, yeah. So factor of 1/4, and it's affecting what? Horizontal. So this is going to be a horizontal. Okay, horizontal what? So the factor is 1/4, right? So think about this. When you multiply something by a fourth, does it get bigger or smaller? Like if you multiply by 1/4 by 0.25, it's going to get smaller. So it's going to be horizontal compression. And so if you think like 4 times 1/4, that's going to get smaller, right? So factor is 1/4. That's a horizontal compression by a factor of 1/4. Now what's happened here? Moving 3 to the right. Okay, so that's a move 3 units right. Okay, good. So the information is given to us. We're gonna create the picture. Let's do the key points. What are the key points here for us?
The fours and at 12, maybe, 12 and 12. And then at 10 and 5. Or 5 and 10, so.
5 and 10.
Yeah, there's that side, but it doesn't look as nice. Or,
Okay, so we could do this one here. I got -6, -20. So let's do that. -6, -20. Is it -5, -10?
-5 and 10. Yeah, but on the other side, it's not like straight bang on.
Mm-hmm. Yeah, that's okay. So we'll do this one here. This is a nice one. We're just gonna sketch it later anyway, right? So just a good general shape. So that's gonna be 0, -16. Okay, and this one here, this is a nice point. 4, 0. And then you said 5 and 9. Okay. I'll just go 6. I'll just 6, -20. Or you go 5 and 9. That's okay too. I'll go 6. There's probably other ones too, right? So 6, -20. That should be enough. We kind of, between those 5 shapes or 5 key points, we can generally figure out what the shape is going to look like. Okay, so what's going to happen in here? Let's do this transformation. So this one here, oh, it looks like it's just going to be X. Only X is being transformed here. The Y is not, right? Because this is horizontal compression, horizontal, so that's affecting the X. Moving left and right, or in this case, moving to the right, that's also the X. So the Y stays the same, except for the X. So let's do that. So what's the transformation? The factor is 1/4. So we're going to put 1/4 X. Right? The factor is 1/4, 1/4 X. And then move 3 units to the right. So that means +3. Nothing is happening with the Y, so I'm just going to put Y. So far, so good? So the B is 4, so the factor is 1/4. Yeah? The B is 4, so the factor is 1/4, the reciprocal. And then moving 3 units to the right, so +3. Okay, so go ahead and figure that out. I'll do the same thing. -1. Yes. And looking at that, does that one look like it's compressed to you?
Yeah.
Okay, so it kind of looks compressed by a factor of 1/4. Okay, I didn't say a factor of 4, but a factor of 1/4. And then shifted to the right 3 units. Okay, good. Any, any questions there?
Can we state the domain range of it?
Oh, that's a good question. That's a good question. Domain, yeah, let's do that, even though it's not asked. What do you think the domain and the range of the transformed picture? Okay, so the domain are the possible x values. So when you can see this here, our graph is kind of hovering around here between like 1 and about 6, right? Or 5-ish. But it kind of later on, it's gonna open up that way. It's gonna get wider and wider and wider. Okay, I'm exaggerating by too wide at the bottom, but it will eventually. So it's gonna be from negative infinity to infinity. And then the range for that one, for the transformed, is from 0, oh, no, negative infinity to 0. Negative infinity to 0. Okay? Is that good?
So we just always assume,
Hmm?
even though we only see this part of the graph,
Yeah.
we're just gonna talk about how it's just gonna.
It will eventually widen at the bottom and it's going to continue all the way down.
I think as long as the lines have arrows at the line,
That means it's going to continue on.
if they don't, then
Yeah, they have the dots. then-
If they have a dot, then that means it stops right there. Okay, let's see this one, example 3. Given the graph of f of x, describe the sketch of a graph. Now, they didn't tell us what the function is. Gonna have an idea what the function is here. It's gonna be, the f of x here is 1 over x. That's how they produce that graph. Okay, but we don't care about what the actual function. Look at the transformation. So what kind of transformation happened here? Start with the 4.
or you can stop.
Yeah, so this is a vertical translation 4 units down. Okay, good. What happened here? The 1/2?
The factor, 1/2, so
The b is 1/2. That's gonna be 1/2. If it's embedded in here in the equation, that's the b value. That's not the factor. Okay. So here, the 1/2 tells us that the b value is 1/2. So that means this is a horizontal. So b is 1/2. What is a factor? 2. Yeah. So horizontal stretch by a factor of 2. And then what else happened here with the +1? 1 to the left. Horizontal translation, 1 left. Yeah? Okay. So we have some points in here. Now, Can you see the asymptotes? Where are the asymptotes here? You have two asymptotes, one a vertical asymptote at x equals to 0. And can you see the other one? So this is x is 0,
Wow.
y equals to 0. That's your asymptote.
How do you know that there is one that y equals 0?
How-
Because they have dotted line.
Yeah, okay, that's a good question. Like how did I know that? Yeah, so it gets closer and closer and closer to that one, but it doesn't really touch it at that
But
point.
it never will. Right?
Nah, never will. Yeah. And we can't verify that because we don't have an actual function, right? But yeah, there's one right there, asymptote, asymptote. So here, a vertical translation of 4 units down. Okay. Vertical translation of 4 units down. Which asymptote gets affected by that? So vertical, if this is my vertical asymptote and I shift 4 down, does the asymptote change? It's in the same place, right? So if it's a vertical translation, it's y equals to 0 that gets translated 4 down. Right. Okay. So we know vertical translation of 4 units down. So it's going to be the y that's going to go 4 down. So let's do that right now. So 1, 2, 3, 4. This is a really nice guide. So you already know where your graph is going to be. Now, a horizontal translation of 1 left. So which asymptote is getting affected? The x equals to 0, 1 left. So it kind of goes this way. So the new asymptote is x equals to -1. Now we can do the sketch now. So what are the key points? I see. Don't forget the 1, 1. 1, 1. Even though it's not kind of given there, it's 1, 1. And the other one is 2, 1/2. The next one was -1, -1. And the other one is -2, -1/2. So let's see what your translation, vertical translation of 4 units down. So that's going to be y minus 4. And horizontal stretch by a factor of 2. The factor of 2. So that means 2x. Horizontal translation 1 left, so it's -1. So everybody okay with that? 2x minus 1. Once you figure this out, I think it gets easy, right? The 2x minus 1, y minus 4. Once you have this written down, it gets easy from there. So let's see that. Okay, so go ahead and let's figure this piece. Okay, is that good? So this is where your graph is gonna be.
Isn't there like zero, in my line, the line has zero vertical to the line.
Oh, you mean this one, the asymptote. Yeah, the asymptote has now moved to the negative one. So yeah, the old asymptote has been moved. So the new asymptote is at negative one. So this graph now, the new graph won't pass the x equals to negative one.
We could always enter 0 in for x to figure out where it crosses the y.
The y-intercept, yeah. Yeah, we can do that. Like, we don't have the exact function, right? Because we have the f of x. We don't have the exact function. Although I think we know it's going to be 1 over x. But yeah, if we do know, then certainly we can figure out the x-intercept, the y-intercept in this case. Because we have an x-intercept up here, y-intercept down there.
How do you get the horizontal?
This one, this one. So the original horizontal asymptote looks like this, right? But then it says here a vertical translation down. So a vertical that affects the y. So it means everything gets shifted down, including the asymptote. Okay, so I think I'm gonna stop right there. We'll give us a little bit of a break because now give you 5 minutes break, and when you come back, we're gonna get the thing started. It takes about 45 minutes, so that's kind of giving us a really good timing. Takes us till about 3:15. Okay, good.